Welcome to the deep dive.
Great to be here.
Today, we're really plunging into something pretty fascinating. It's about making AI, specifically large language models, LLMs, well, smarter and faster when they need to think.
Right, when they need to reason through stuff.
Exactly. We're looking at a paper introducing this new idea called AutoThink.
Yeah, AutoThink. And our goal today is really to unpack it. What's the actual problem it's trying to solve? How does this thing work?
And importantly, why might it be a big deal for how we use these reasoning models going forward?
Definitely, because, we've all seen LLMs do amazing things with that think step-by-step prompt.
Oh yeah, chain of thought. It's often crucial for getting good answers on tough questions.
Totally unlocks capability.
Yep.
But there's a catch, right?
There always is, and this one's pretty noticeable if you've used them a lot. All that thinking. It generates a ton of text, so many intermediate tokens.
Piles up. And generating tokens costs. It takes time, it takes compute.
Which is fine maybe in a lab, but if you want these things running quickly, maybe on your phone or in an app that needs fast responses.
That inefficiency becomes a real bottleneck, a growing problem.
Okay, so let's elaborate on that problem AutoThink is tackling.
Yeah.
This inefficiency. What does it actually look like?
Well, the paper kind of highlights two main issues. Sometimes the model just overthinks.
Overthinks, like
Yeah.
too much detail.
Yeah, generates loads of steps, maybe redundant ones, things that don't really help push the reasoning forward. It's like writing a 5-page essay for a 1-sentence answer. Just wasted computation.
Okay, that makes sense. And the flip side?
Underthinking. Sometimes it just jumps to a conclusion too fast, doesn't do enough deliberation. So the paper really questions this idea that just generating more tokens, throwing more compute at it, always means better reasoning. Sometimes maybe just adds noise or confuses the model.
Right. More isn't always better.
Exactly. So AutoThink steps in. Instead of just more tokens, let's be smarter about the process.
Okay, smarter inference.
Well, AutoThink is all about improving inference efficiency for these reasoning LLMs, getting better results, ideally, with fewer resources when you actually ask the question.
And it does this by tackling two things you mentioned.
Yeah, two main things. First, deciding how much reasoning, how many thinking steps are actually needed for this specific question.
So not a one-size-fits-all approach.
Nope. And second, actually guiding the reasoning process while it's happening.
Guiding it. Okay, now I'm intrigued. How does it guide the model's thoughts? Let's get into the components.
Okay, so the paper breaks AutoThink down into two core parts that work together. First up is the query complexity classifier.
Classifier. So it's sorting the questions somehow.
Kind of, yeah, but based on how much thinking they seem to need. Its job is to look at your question before the LLM dives into the detailed step-by-step stuff.
Right.
And predict the sort of optimal number of reasoning tokens needed. It sets a thinking budget, basically, dynamically.
A budget for thinking. How does it know what budget to set? Just a guess.
No, it's trained. They use a calibration data set. So examples of questions linked to successful reasoning chains, showing how many tokens it actually took to get the right answer in those cases.
Oh, okay. Learning from experience.
Exactly. It uses adaptive classification to learn patterns. What does a hard question look like versus an easy one in terms of likely reasoning length?
And it puts them into categories.
Yes.
Yep.
The paper mentions 3 levels. Low complexity, maybe needing 0 to 500 tokens. Medium, say 500 to 1500. And high, needing 1500 or more.
And why is that distinction so important?
Because, like we said, giving a really complex problem only a tiny budget means it'll likely fail.
Right. Underthinking.
But giving a simple question a massive budget is just wasteful. Overthinking, wasted compute. So matching the budget to the need is key.
Okay, so step 1. The classifier figures out the budget. Let's call it T tokens. What's the second piece? The guidance part.
Right, the guidance. That comes from the data set of control vectors.
Control vectors. Sounds a bit sci-fi.
Yeah, a bit. But these are what provide the steering. They're designed to gently nudge the LLM's internal state during the reasoning process.
Nudge it where?
Towards paths, towards ways of thinking that are more likely to lead to a correct answer, less likely to get stuck or go off track.
How on earth do you create something like that? A vector that steers thought. The paper mentioned pivotal tokens.
Yeah, this is the really cool kind of novel part. Pivotal token discovery.
Pivotal tokens, what are they?
They're basically words or parts of words, tokens, that show up way more often when the model is reasoning successfully towards a correct answer compared to when it fails.
So like key concepts or logical steps that good reasoning paths tend to include.
That's the intuition. They find these by taking a benchmark dataset, like Optimal and Bench,
Okay.
generating tons of reasoning attempts on those problems. Some work out, some don't, and then doing statistical analysis. Which tokens are significantly overrepresented in the good attempts? It's a search process.
A search for the good thinking markers.
Pretty much. And they actually open source the tool for this, the Brits repository for pivotal token search.
That's good. Makes it more concrete. Okay, so you find these crucial pivotal tokens. How do they become control vectors?
Right, that's control vector generation. Once you have a pivotal token, you need to capture its essence, its direction within the model's internal world, its embedding space.
The high-dimensional space where it represents meaning?
Exactly. They essentially look at the internal representation, the embedding of that pivotal token, and compare it to the average representation of less important tokens nearby. The difference gives you a vector.
A vector pointing towards goodness.
Sort of. A vector representing steer the model's internal state more in this direction. And these vectors are calculated and stored.
Okay, wow. So you've got the classifier setting the budget T, and you've got these control vectors ready to provide nudges. How does it all work together during inference when I ask a question?
It comes together in the guided decoding with token budget phase. A query comes in. First, the classifier assigns the budget, T tokens. Then the LLM starts generating its reasoning steps. But it's not just running free. At each step, or maybe key steps, the system applies the relevant control vectors.
Adding those nudges you mentioned.
Yeah, gently pushing the model's internal state, encouraging it to generate tokens that align with those pivotal concepts we found earlier. It's like subtly reinforcing good thinking habits.
Like a helpful guide whispering, maybe think about this aspect based on past successes.
That's a decent analogy, yeah. And this guided generation continues
Until
the model hits that token budget, T.
the timer goes off.
Exactly. Once it hits T tokens for the reasoning part, that's the signal. Okay, stop the step-by-step, now generate the final answer based on the thinking you've done within this budget.
So it forces focus, prevents the endless rambling, the overthinking.
And hopefully, because of the guidance, the thinking it did do within the budget was more effective, more direct.
That is a really neat mechanism, but the proof is in the pudding. Did they test this whole AutoThink system?
Oh yeah, they ran experiments to see if it actually delivered.
What did they test it on? Easy stuff.
Definitely not. They went for hard reasoning benchmarks, specifically GPQA Diamond, which is known for needing really deep, complex reasoning.
Right, notoriously difficult.
And also MMLU Pro, which is a broad test of complex questions across lots of different subjects. These are designed to really push a model's reasoning limits.
Okay. And which LLM did they use?
They use a model called DeepSeek R1 DistillQuen 1.5b. It's one that's specifically been worked on for reasoning tasks.
Makes sense. And the comparison, what was the baseline?
They compared AutoThink against two main things. The vanilla model, just the same DeepSeek model running normally, without AutoThink's budgeting or guidance.
A standard chain of thought, basically.
Pretty much. And also a fixed budget approach. This one did use a budget based on complexity, but it didn't have the dynamic classification during inference or the control vector guidance.
Yeah.
More rigid.
Gotcha. All right. The moment of truth. The results. This is where things get interesting, right? Because less thinking should mean worse answers, usually.
That's what you'd normally expect. But this is where AutoThink delivered a surprise, especially on that really tough GPQA Diamond dataset. The results were, well, quite dramatic.
Okay, lay the numbers on us. What did they find?
So on GPQA Diamond, the standard vanilla model got an accuracy score of about 21.7%. And to get that, it used, on average, nearly 8,000 reasoning tokens.
Okay, 21% accuracy, 8,000 tokens. And AutoThink.
AutoThink boosted the accuracy significantly up to over 31%, while using, on average, only around 3,500 tokens.
Hold on, let me get this straight. The accuracy went up substantially.
Yes. The paper highlights it as a 43% relative improvement in accuracy.
While using less than half the reasoning tokens.
Exactly. Using 55% fewer tokens on average for the reasoning.
Wow. Okay, that is the aha moment. Better results with way less work.
It really is. It challenges that core assumption. More compute doesn't always equal better reasoning, especially if it's unfocused compute. Smart compute can be better.
Did this hold up on the other dataset, MMLU Pro?
It did. The gains weren't quite as massive percentage-wise, but still significant. About a 3% absolute gain in accuracy and around a 37% reduction in tokens used. So the pattern was consistent.
So AutoThink seems to show you can have your cake and eat it too. Better accuracy and better efficiency.
In these reasoning tasks, yes, that's what the results suggest. overcoming that typical trade-off.
Did they look at why? Like the qualitative analysis? What did the reasoning actually look like?
They did, and qualitatively, they found the vanilla model's reasoning could be, well, kind of meandering, redundant steps, losing the thread sometimes.
Right, the overthinking.
Yeah. The fixed budget approach, because it was rigid, sometimes cut off reasoning too early on complex problems. It needed more steps, but didn't get them.
The underthinking trap.
Exactly. But AutoThink's reasoning paths, they tended to look more focused, more direct, seemingly hitting the key logical points more efficiently.
That makes sense given the guidance. So, zooming out, what are the implications here? Why does this matter for people actually wanting to use LLMs?
I think it's potentially huge for practical deployment. Imagine trying to run sophisticated reasoning on your laptop or a phone or some edge device without massive cloud resources.
Right now, that's often too slow or just impossible for really complex tasks.
Exactly. AutoThink suggests a way to make powerful reasoning more feasible in resource-constrained environments, or just faster everywhere. It implies we should be putting just as much effort into optimizing inference, how the model uses its knowledge as we do, into just scaling up the models themselves.
Making advanced AI thinking more accessible, more practical.
That's the promise. Now, it's important to be balanced. Like any new research, AutoThink has limitations in areas for future work.
Of course. What did they point out?
Well, for one, that query complexity classifier needs good training data, that calibration data we mentioned. Creating that might not be trivial.
Okay.
And the pivotal token discovery process itself can be computationally heavy. Finding those key tokens takes analysis.
Right, it's an upfront cost.
And there's the question of generalizability. Will control vectors trained on one model or dataset work well on a completely different one? Maybe not perfectly without adaptation.
So future work is probably about making it easier to train, more efficient to find the tokens, and maybe more transferable.
Precisely. Making the whole process lighter, more adaptable, maybe extending it beyond just text reasoning. Lots of avenues to explore.
Okay, let's try and wrap this up. What's the big picture takeaway from our deep dive into AutoThink?
I think the main thing is AutoThink is this really innovative approach. It tackles LLM reasoning efficiency by being smart about how much thinking to do and guiding that thinking.
And the really exciting part is that it seems to achieve both better accuracy and much better efficiency, at least in these challenging reasoning tests.
Yeah, breaking that expected trade-off. It strongly suggests that strategic, guided thinking can be more powerful than just brute force computation. Smarter, not just bigger.
And it's great that they've open-sourced parts of it, like the pivotal token search at that GitHub link, https://github.com, codes the community build on it.
Definitely.
So, for you listening, why should AutoThink stick in your mind? Well, because as these powerful AI models get woven into more things we use daily, especially for tasks needing actual thought.
Yeah, not just spitting back facts, but real reasoning.
Techniques like this are what could make them actually work well in practice. Fast, affordable, reliable. It could mean you get better, quicker answers for complex stuff, even without needing a supercomputer.
And maybe it leaves us with a provocative thought to chew on. If we can get better reasoning with less computation through clever strategies like this dynamic budgeting and guidance, what does that mean for the future?
Could the cutting edge of AI shift? Maybe less focus on just building monumentally huge models?
And more focus on developing these kinds of smart, efficient inference techniques.
Yeah.
Making the models we have think better, not just bigger.
Something to consider. Thanks for joining us on this deep dive.